Hello students, this is example number 2 on wind load calculation. In the previous video, you have seen half example, and in this video we are going to revise that and we will complete this problem of other half. So let us start. So in this problem, let us have a brief. Length 48 meter, width 40 meter, height 34 meter were given. Story height was 3 meter. Frame spacing or bay width in both the direction was 4 meter. Chennai was the location. Terrain category 2 was given. Slope of ground 10 degrees. Height of hill is already given 900 meter. Location from the crest in windward direction, that is 200 meter, and design life period 55 years. So in this problem we understood the plan first. In that plan we see 4 meter bay width in both the direction, in perpendicular to the wind and parallel to the wind. So moving forward, we found out and calculated step 1 and step 2, Vz and Pz. For Vz, we found out Vb from the table. We found out K1, K2, K3 and K4 according to previous video, as well as value for K1 was 1.01, Vb was 50 meter per second for Chennai, K2 was tabulated in this form, K3 was find out like 1.15, K4 was 1. After that, we found out KD, KA and KC. KD was 0.90, KC was 0.90 and KA was interpolated and found out as 0.96. After that, we found out one table. In this table, the values are tabulated for Vz, then Pz and Pd. These three are most important factors of these problems. So let us have a brief. 10 meter height PD was 1573.56, 15 meter height 1734.93, for 20 meter height 1801.56, for 30 meter height 1974.25, and 34 meter height it was 2009 Newton per meter square. So after finding out PD, I will move to step number 3. Let us move to step number 3. Design wind load F. For F, we need three things: CF, A and PD. Third thing, which is PD, we just found out in step 1 and 2. So PD for all the heights, I have that. Now, CF and A should be found out. Let us see that. Here, one figure which is 4B should be used. In that, we have to input h by b and a by b values. For h by b and a by b, I will need three things: h, a and b. Now, h, height of the building, will be same as 34 meter. Now, for a and b, we will take whichever the dimension is larger from a and b is perpendicular to the wind. So 48 meter is larger among 48 and 40 meter. So we will take 48 meter perpendicular to the wind so that the design will be safe. So B is equal to 48 meter, A is equal to 40 meter. So I have got A, B and H, all three dimensions. Now I can find out H by B as 34 by 48, it is 0.708, which is less than 1. Same way, I will find out A by B. A by B 40 by 48 comes out as 0.833. Now let us come to the graph. Graph from figure number 4b. Now, if we input A by B and H by B values, we will get CF. Here, by my observation, H by B and A by B both are less than 1. So, 4B graph is chosen, and from that, if my h by b is 0.708, 0.7 we can say. So it will be below these, because this line is h by b zero point 0.5, right? 1 by 2, that is 0.5. So the values should be below this, and the graph will move like this. We can assume we have to take a hypothetical graph, as this line is not clearly given for 0.708. We have to assume the line going like this and meeting here and like this. Okay, that is our hypothetical line for h by b, and for a by b value is 0.833. So 0.833 will be somewhere here. So the line which is like this will meet the hypothetical line which is drawn like this. So the value should be somewhere here, and the value is taken as 1.15, which is between 1 and 1.2. So it is 1.15. Now I got CF. After CF I will move to AE. For AE, I know what is AE? Area, which is effective frontal. So in this some dimensions should be there, because frontal area, which is fronting the wind. So it is with a formula that length of building or length perpendicular to the wind load by total number of columns in that direction. So 48 by 13. Now 48 is the length. So 48 is the greatest dimension or length. So we have put the wind across or perpendicular to the greatest dimension in the plan, that is 48. One thing. Now if the length is 48 meter, how many columns will be there? 4 meter a bay width. So 12 into 4, that is 48. So 12 plus 1, 12 base. So 13 columns will be there. So here 48 by 13, and effective frontal area E comes out as 3.69 meter square. Now I have got all three things: PD from previous calculations, CF and AE. So I will put the table here in this height PD that was found out from previous calculations, F, that is CFA into PD, that we can calculate now, and from that load I will convert the load in kilonewton per meter as usual, because the load will be used in kilonewton per meter. Let us tabulate that. Here 10 meter, 15 meter, 20, 30 and 34 meter height is kept according to the previous table only. Now PD values are derived from the previous table which we have calculated here. All the values are written same from this table. So these are the values. Now if I multiply PD with CF and AE. CF is taken as 1.15 and AE is taken as 3.69, and PD for individual heights like this. I will get my design wind load in Newton per meter. So I have these values: 6671.89 to 8518.16. Now converting it into kilonewton per meter, to convert Newton per meter into kilonewton per meter, it is multiplied with 10 raised to minus 3. So that I am getting kilonewton per meter design wind load. Let us move forward. So generally, overall depth of the beam is assumed as 500 mm. In previous problem number 1, we have samely assumed D, overall depth of the beam, as 500. Now, keep your attention here. We are going to learn nodal length distribution as well as how to calculate length of the node, etc. Here I have shown the foundation, or we can say floor slab. These three things are shown here. This gray one is a beam, this orange one is a column, and this green one is a slab. So it is below ground line, or we can say at node 00, or we can say node GG. So this green slab is known as floor slab. It is below the ground line. Okay. Now generally we assume below the ground line 2 meter height is there, and 1 meter height is there for the slab and beam. Now for nodal load calculation and nodal distance calculation, if the node is in the center of the beam, node is in the center of the beam always. Now to check that and to check that distance, I have assumed a total 1 meter height up to from ground line to bottom of the beam. So total height, this height will be getting like 1, that is minus 1, plus half of the overall depth of the beam, that is 500 by 2. So I will get node 00 or node GG height from ground line as minus 0.75 meter. Why it is minus? It is below ground line, right? That is why it is written as negative. So node 11 is 0.75 meter, which is negative from ground line. Now moving to node 11 or first story. Again, this orange is column, beam and slab. So half of the beam will be my nodal point. So my node 11 will be located here. I have taken, or I am told that height of the story is taken as 3 meter. So total height is 3 meter. From 3 meter I will deduct half overall depth of the beam and 3 minus 0.500 by 2. So from ground line the distance of node 1 will be 2.75 meters. Furthermore, for node 2, again story height is 3 meter uniform, and the distance from this to this will be 6 minus half of the overall depth of the beam, which is 5.75 meter. Same applies for 3 and 4. From problem 1 and problem 2, you should be clear up to this. Let us move to another area, which is this area. In this, here, my ground story, or if I focus on node GG, and if I talk about nodal range or distance from node below the node and above the node. So for this ground story, the nodal height distribution will be half of both of them. From 0 to, if I start here, that will be 2.75 by 2, and 2.75 by 2 comes out as 1.375. So if I distribute the length over these nodes, first distribution will be like this, from ground line to this. Second distribution will start from here to here. Let us see that in the table. In this table, nodes are given in the first column. Minus 0.75, as we have seen. Minus 0.75. First node is at 2.75. 2.75. Second, now if we add 3 story height in all the node, we can get the next one like that. And the topmost will be having some parapet. So here 2.75 plus 3, 5.75 plus 3, this plus 3 plus 3 plus 3, we can get up to this. So I have got all 12 nodes, 0 to 11. Now loading level. To understand loading level, we understood these. For starting from baseline or ground line to the first loading level, first range of loading level will be 0 to 1.375. So 0 to 1.375. Now at node 11, the distribution will be at node 11 will be half story above that and half story below that. But where to start? We have to start at 1.375 and 1.375 plus half of this story and half of this story. So I will get 4.25. For next, at node 22, what will be the loading level? At node 22, half of this story and half of this story will be considered. So it will start from the previous value as 4.25 and end on the top value 7.25. So this is how we can prepare all these loading level values. And at last, we have to incorporate total height of the building including parapet. Now, let us understand third column, which is load kilonewton per meter. Now, I have these value kilonewton per meter as in the previous table as for 5 heights only, which are they? 10 meter, 15 meter, 20 meter, 30 meter and 34 meter. These are the values I already have. But I will need all these values for different nodes because I want nodal distribution of load, right? So to get these values, I have to interpolate my already got values, which are these five. So up to 10 meter, it will be constant 6.67. So up to 10 meter height, 7.25. Now 10.25 will be greater than 10. So that value will be changed. But up to 10 meter, it will be constant. After that, I have to interpolate. So for 10.25, let us interpolate. Now for 10 meter, I have the value is 6.65. For 15 meter, I have the value is 7.36. So for 10.75 meter, how much will be the value? Let us see. I have value for 10 meter 6.67, 15 7.36. Now, if the gap is of 5 meter, if the gap is of 5 meter, then the gap is 0.69. Then in 10 and 10.25 there is a gap of 0.25 meter. So how much will be the value? For that cross multiplication will be required, and after cross multiplication I can get the gap is 0.0345. So adding the gap in the base value of 10 meter, I will get the value of 10.25 meter as 6.70. You can check that it should be in between 10 meter and 15 meter values. So 6.70 is in between both of them. So I am correct. Same way we can interpolate for 16.25 meter, as 15 meter value is 7.36, 20 meter value is 7.64. So for the gap of 5 meter, the gap in the values is 0.28. So gap of 1.25 meter, how much will be the gap? So gap is 0.07 and I can get value of f for 16.25 meter as 7.43. We can again check that it should be in between both of them. It is, so I am correct. Now according to same method, I have to calculate all the values at all the nodal points. So I will get and I will have an idea of all kilonewton per meter values of the load. So my column number 3 is prepared. So starting from the below, that is a gap or loading level distance, that is 1.375 into the load in kilonewton per meter. So the load 6.67 into 1.375 will make 9.17, which is nodal point load at node 0, 0. Same goes for all the nodal points. Let us see for 1, that is there is a gap of 4.25 minus 1.375, somewhat gap is there, into the load in kilonewton per meter will get me 19.80. Furthermore, the gap will be uniform in this all. So gap will be of 3 meter, which is a story height after second node. So 3 into 6.67 will 20.01. Again 3.3 into 6.7 will give this. So these nodal point loads are grabbed or taken by this method. Now they will be utilized further for preparing graphs. Two graphs are there. One A is wind pressure diagram and second one is nodal point load diagram. These two graphs are merged and are resultant of these problems, or we can say solutions of these problems. So let us have a vision of that graph. Here I can see first wind pressure diagram. It is showing pressure according to the nodal heights. So from minus 0.75 to 32.75, the wind pressure is shown here. Same goes for these values 0.75 to 32.75 nodal point loads are shown here like this for all nodal points. So that's it. In the second problem, we will learn more of this in the next video. Thank you.